Okay, pause the video and copy this down. So, you know what a derivative is. So what do you think an antiderivative is? Well, we're going backwards, aren't we? So for part A, I'm asking, how do I go backwards from 2x? Well, the derivative of, x squared would be 2x. B, x to the 5. Okay, if I do a derivative here, I get this guy. C, you'd say, well, if I'm going backwards, I would get x cubed, but I'm going to have to divide by 3. So that when I do a derivative here, this 3 will come down, cancel with this 3, and give me x squared. And D, we get 3x. Okay, this introduces the topic. So let's write a definition now. We say f, capital F, is an antiderivative derivative of f, small f, on an interval I. We'll talk about I later. If capital F prime is equal to f on I. Okay, you have all this business with I, which we'll talk about in a second, but I want you to focus on this equation. Capital F prime is lowercase f. Okay, I is an interval, so for us that will be a closed interval or an open interval or some kind of hybrid. Like so. This could be A or B. Let's say in this case, A or B could be, so B could be infinity here. And A could be minus infinity. Okay, so those possibilities are not excluded. Okay, let's try some exercises. Okay, so when I write exer, that means I want you to try something. Find an antiderivative of 4x cubed, b 16x 15, c just x, d just 5, e x, and let's say f 1 over x. So pause the video, copy this down, and give it a try. Okay, copy, 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 pause, pause, pause. Okay, here we go. Here are my answers here. x to the 4, b x to the 16, c x squared divided by 2, d 5x, e, well, just e to the x, right? Because the derivative of this is e to the x. And f, you have to remember that the derivative of ln x and we're going to put absolute value of x. Maybe I'll talk more about the presence of the absolute value later.